Good day. This is Mr. Stolle. So today we are looking at circle geometry. Now, when you look at circle geometry, we see that we need to understand the circle itself. How is your circle? And we have here the line that passes through the center and touch both sides of the circle is what we call a diameter. So this is a diameter from this point here until this point. It has to pass through the center for it to be a diameter. Then half of that diameter, we call it a radius. We call it a radius. And the line that doesn't pass through the center and touch both sides of the circle is what we call a chord. Now a chord, by split your circle into a minor segment and a bigger segment, now, or what we call major segment. Then we have what we call a second that crosses the circle. It doesn't pass through the center, but it's it touches the circle and actually pass the circle out, and pass through there. Now, we have another important line that we will deal with mostly is what we call a tangent. A tangent touches once your circle. It touches once your circle, and your tangent is perpendicular to the radius or perpendicular to the diameter, meaning to say it forms 90 degrees, what we call with your radius. Where it touches the circle, if we draw a radius there, we actually have a 90 degrees. So your radius, which is r, we get it by saying diameter divided by 2, because what we call your diameter is actually, we don't normally use the diameter, we normally use what we call radius in most calculations. Okay, now let's move on to groups of theorems. What is it? Geometry, circle geometry theorems that you need to understand. So we have got the center group. Now with the center group here, we are looking at a radius, not a radius, sorry, a line from the center, which is perpendicular to the chord. So we are saying if the line from the center is perpendicular to the chord, it bisects the chord. If it is perpendicular to the chord, it bisects the chord. So line from the center, it's perpendicular and also bisect the chord. So you must understand this theorem here. Then the other theorem is that angle subtended at the center by the arc. So here we have got an invisible arc here. We have an invisible arc here, a straight line here. That's what we don't see. So this arc here is subtending one angle at the center, which is this one, and the other angle into the what you call on the circumference. So we are saying this is twice the angle on the circumference. That's what you must know. And also it goes both ways now. It say if this angle here, the angle outside here is also twice the angle here, this side here on the circumference as well. So that's what you must know. Then again here, applying the same concept of twice the angle at the center. Here we have got a diameter, a semicircle diameter here. With the diameter now, it subtends an angle of 90 because it is 180 here, and it subtends an angle of what? Of 90 on the circumference. So we must know that angle subtended by the diameter on the circumference is a right angle. So we must look for that. Then the other thing that you need to understand here is that when you have a diameter here, you must know that line from the center to any part of the circle, we call it a radius, and those radius, they are all equal. They are all equal. So what we have here is that we have an isosceles here because the both sides here, because these two are radius and they are equal, and it makes these angles actually equal as well because base angles of isosceles. So this one becomes what we call isosceles now. So it becomes what we call an isosceles. So this is what you need to remember here. And another thing here is that exterior angle of a triangle, if we are to look this as a triangle, besides we're not looking at it as a circle, if I look at this as a triangle, what we know is that if we have let's say we have got this theorem here, this is maybe let's say x, this y, then maybe this is p. Okay, so what we know is that p is equals to x plus y. Exterior angle is equal to sum of opposite interior angles. That's what we have there. So you must always also apply it. You must apply it also inside circles as well. Because when you're doing circle geometry, or should I say Euclidean geometry, you need to look into a lot of factors there. You need to look, you don't need to restrict yourself what you call to one particular subject. You need to actually link up a lot of things. Okay, so you need to bring up a lot of things here, and bring up the triangles, different terms of triangles. Like here we have got an isosceles. Where is it coming from? Because we are saying this radius, they are both equal, and they makes them the base angles are also equal. But we are also saying the exterior angle is also sum of opposite interior angles. We also need to understand that. Then let's move on to another theorem. No center group. So here we don't have a center. We don't have a center. We don't have a center here. So we are saying angle in the same segment are equal. Angle in the same segment are equal. Now, and just to draw this one here, normally you don't have this arc here, this what call this chord here. What we have here is this chord here. We normally, it's not normally shown, is you just see a circle, and when you see a circle, you just see what is it? Something like this. But what you need to know that is that you have got a chord, because you trace your lines if they are coming from same point, and how many lines are starting from same point and ended at the same point. Whatever angle they form, they should be equal. So you, like here, you start from this point, you go up, you come down, you see that there's another line again starting from the same point, you go up and it ends on the same point. So whatever angle they subtend there on the circumference, they should be actually equal. That's how you do it. But another thing again, remember when I give an question paper, don't just work with the question paper like this. Also try to twist your question paper, twist your question paper, twist your question paper. As you can see now, this is more visible now if you are to look on these angles here after twisting your paper. So you need to twist your paper so that you can understand it, especially when you're dealing with what we call circle geometry. Now, so you're saying angles subtended by the same chord are equal, same chord. We are saying this is the same chord subtending what called two angles there, and they should be also equal. So this is the same one and the same thing. Now, another thing again is that you can be given equal angles here. You can be given equal angles here, and you need to apply that now. Once you have got same size of angles here, it means that the chords, they are actually of the same length. So equal chords subtend equal angles, and vice versa. Equal angles are subtended by equal chords. So you must also understand that. That's another theorem that you must know. Then let's move on to tangent group. Now, when you look at the tangent group, you have two ways to prove that is what is a tangent. Now, the first thing here, tangent is equal to the radius at point of contact. So as long as you're able to prove that this line here, these two are perpendicular here, it means that what is it? It forms what is it? It's actually a tangent. So a tangent is perpendicular to the radius. It forms 90 degrees there with the radius. Then the other thing again is that angle between a tangent to a circle and a chord drawn from the center of contact is equal to the angle subtended by the chord in the alternate segment. So we call this tan chord theorem. So tan chord theorem, we are saying this angle here is equal to opposite angle here inside the angle subtended by the chord. So we are saying tangent and the chord. The angle subtended by the chord from the tangent is what is equal to the angle which is formed between the chord and the tangent. That's what it's just saying here. So tan chord theorem, you check whatever you have here. You check what is my chord from the angle here? Does it have any angle on the circumference? This should be equal to the angle actually outside here. Then the last part of what call the tangent that you need to know, that tangent to circle from a common point are equal in length. So these two, they are equal in length. You need to understand this because sometimes they have drawn a lot of things here and they've got a line also that goes there. So you actually see that this angle here, these angles here will be equal because these two sides, these two will be equal. So you'll be looking at an isosceles again. So these are things that you must look into and understand what's going on. Now let's see cyclic quadrilateral group. Now when you look at this, we are saying angle in the same segment are equal, remember what we have just started now. We know that angles here that we have in the same segment, they should be equal. And remember here, these are very easy to see, but when you see these angles here, how do you get to see them nicely now? You have to twist it like this, and you can see that it's starting from this point line, it goes there, subtending an angle there, then goes there, it's subtending another angle there. So these two should be equal, okay? Then if you do this again, you find that this angle here and this angle here are subtended from by the same chord, which is this chord here. So we're saying it goes there, and actually form what call an angle. So those angles should be what called the same. Then another thing that that you need to understand with cyclic, that you need to use it in most cases, that x plus y opposite angles of a cyclic quad only in a cyclic quad are supplementary adding up to 180. Supplementary, it adds up to 180. So this is what you need to understand. Opposite angles of a cyclic quad should be equal to 180, because sometimes you ask to prove that it's a cyclic quad. How do you prove that if you don't know how you prove it? You prove it. This is one of the one way of also proving that the opposite angles should add up to 180. And if they've stated that is a cyclic quad, you must assume now that opposite angles, they should add up also to 180. Then you need those answers to actually calculate your angle, size of angles, and also it can be, I don't know, but you need to understand that part, that you need to prove by knowing the size of the angle that they should add up to 180. Now, the last part here, exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So exterior angle here is equal to opposite interior angle. So the opposite interior angle here, remember here. But this concept here, remember, is just the same as the one, if you are trying to link it, what we talk about here, that P and X and Y, saying that P is equals to X plus Y. Why is it like that? Because we know that some of these interior angles, they give us what we call 180, and also the straight line give us 180. So we are saying here, what's short here to get 180 is X plus Y. So which is this, which is what we call, if we add X plus Y, we must get what is it? And this angle here, let's take this angle, maybe U. So if we take P plus U, it must give us what? 180. So P plus U must give us 180. But also U plus X plus Y must give us what? So X plus Y plus U must give us what? 180. Then we are left with the U here. You find that this will be actually equal. That's what we are saying here, X plus Y. Then the same applies to here, is that a straight line here, a straight line is 180. So what's short here is this angle here. And from this also, this angle, if you add it to this angle, it must also give you 180. That's why we are saying these two should be actually equal, okay? Exterior angle. But now let's look at the last part here that I want to show you, proportionality theorem. Proportionality theorem, remember we've done the quadrilaterals, you have done, now we are looking at what called proportionality theorem. These, you will see them in the circle. You will see them in the circles, and you need actually to work them out. So you need to link a lot of stuff there. Now, we are saying that proportionality theorem says a line drawn parallel to one side of the triangle casts the other side, the other two sides, so as to divide them in same proportion. So we're saying if this line here is parallel to this line here, one side part of the triangle, we are saying the two sides here, they are actually cut in same proportion. They are actually in the same proportion, meaning to say AD over DB will be equals to AE over EC. That's what it means. But now, how do you prove that? How do you prove that what is it? AD is over DB is equals to AE over EC. Now, when you want to prove here, what you need to do is that you are going to deal with what we call area. So you're going to deal with area, and when you're dealing with area, you will need height. You need height, and where do you get that height? We are saying here, if we are to take this from, let's consider this part here, for this triangle AB ADE, we can say the height of this should have it, should cut there. Perpendicular height. So this is our perpendicular height. Okay, this is our perpendicular height, and our perpendicular height we can call it K. And let's also have a perpendicular height on this side. So we're saying perpendicular height must form 90 here. It also must form 90 here, and we call this H. Now we are saying for us to calculate triangle of A, let's also count this triangles. So this is what you need to have here. You need to draw this line that I'm drawing here. In order for you to prove this, you need to draw these lines, and these lines will give you what called triangles. Now, what we're having now is that we have got height here, and we've got height of K, and also have height of H. So now what we are saying is that for us to calculate area of what is it? Area, we're going to say area of triangle ADE over area triangle BDE. So BDE. So these two triangles here, we're saying if we had to use this triangle here, we would say BDE and of what we call ADE. What we have to find here is that we are going to say for this triangle here, we are going to say the base will be what? The base will be half AD times H over half BD times H. So we are saying for this triangle here, its height is H. Its height is H. This is what we have. Its height is H. Then for also for AB, what we call ADE, the height also, we can use two different heights here, H or K. So we're saying it's a triangle like this. That's what we're dealing with here. So you need a height, perpendicular height here that you will deal with. But this height also, you can even use this height as your height. It's still the same way. Okay, that's what we're talking about there. Then this one will give us what? We will have to cancel H and H because the same, and half here, we will left with AD over BD. Then another thing again, we can also calculate area triangle ADE over area triangle. Now we're looking at A, where is it? Sorry, ADE. Now we're looking also CED. So CED. Now with this now, what we have now, we are looking at height now of K. Height of this triangle here, because remember it's not a right angle, it's a right angle triangle. We are saying if we have got a triangle like this, its height will be this. That's what its height should be. That's what we're talking about here. That's what we're talking about here. That's why we're saying the height of this triangle here, CED, should be actually a K, should be equal to your K. So if you have to put it like this, we can actually see clearly now that the height CED, the height is actually K. That's your height. And we are now saying, let's put it there. Let's say we are going to say it's going to be half AE times K, half AE times K over half CE, EC, and say EC times K. Then KK cancels. Then we have got AE over AC. EC, sorry. AE over EC. Now, when you have got AE over EC, now we can see that these two are triangles. These two are triangles. So what are we going to do? We're going to say area triangle of ADE over area triangle BDE is equal to area triangle ADE over area triangle CED. Now, from there, now we know that we're just gonna say this is what we have: AD over BD should be equals to AE over EC. Proven. So that's how you prove what you call this theorem here. That's how you prove the proportionality theorem. We're going to prove some of the what you call the theorems, also psychogeometry, so that you can understand how you're supposed to prove them. Okay, thank you so much.